So it's 9 o'clock. Let's get started. Welcome to Tea Science Tuesday. This is about theanine today. I was going to say which number it is, but I can't remember. I guess this is the fourth one now. Had to cancel last week, but you know what? It worked out all right. If you take a look at my website, ericarscott.com, there's a blog post about this Tea Science Tuesday series, and there's a syllabus. And last week, it was supposed to be about Eastern Beauty Oolong, which is the topic or a big part of my PhD dissertation. And you know what? We already really talked about it in the episode about volatiles. So there was really nothing more for me to say. But if you want to watch that one, it's up on YouTube now on the Tea Geek channel, which is a YouTube channel I've been associated with for a while now. Welcome, InstaWeb. Cool. So today we're going to talk about theanine. I'm drinking, I was supposed to be drinking gyokuro. That was my suggested tea, but I forgot my gyokuro at work. So I'm drinking sencha, which is sort of the next best thing. And it does have still a lot of theanine, not as much as gyokuro would, or I could have put matcha also. Matcha would have been a good suggestion for today. That's something that's really high in theanine. So we're going to go through sort of what is theanine, what is it, why is it in tea plants, what does it do for us as humans, how does it affect us, and then how does it get into the tea to begin with? How do we get teas like gyokuro and matcha and anji baicha is another one I'll talk about that are all really high in theanine. So theanine is an amino acid. Amino acids are a group of chemicals that are the building blocks of proteins. So if you break down proteins, you get amino acids, or the other way you can think of it is you have to use amino acids to build proteins. Theanine is kind of a unique amino acid. I wouldn't say unique. It's not. It's just not very common in the world, in living things. Most plants have used glutamine as their number one amino acid that they have that they use. So what theanine is used for, I'll start with that, in tea plants is for transporting nitrogen from the soil up to the leaves. So theanine gets made in the roots and then it gets transported throughout the plant to deliver that nitrogen. So amino acids are nitrogen containing compounds. When you fertilize a plant, it takes up that nitrogen and part of it gets transferred into theanine, if it's a tea plant, or glutamine, usually if it's some other plant, and other amino acids too. And they get transported throughout the plant and drop off their nitrogen at the leaves. So what makes theanine kind of unique? Well, it's just a modified version of glutamine. It's really similar in structure, but it's in extra high concentration in tea. Even within the Camellia genus, so other camellias like Camellia japonica, those are the ornamental camellias, they make some theanine, but not nearly as much as tea does. So tea is actually pretty unique in how much theanine it makes. And it's maybe one of the reasons that tea became such a popular beverage and not some other plant. Welcome, Eric. Hi. So one of the reasons I'm looking at my list of things and going, do I have that much to talk about? So one of the reasons that theanine, or one of the things that theanine does in tea is it gives it an umami flavor. So umami is one of the basic tastes. We can taste sweet, salty, sour, bitter, and umami. And so that last one is maybe less commonly heard of. People maybe haven't heard of it as much. It is like a newer described taste. It's always been there. We've always been able to taste it. But it was only described relatively recently. And it was described by a Japanese researcher, and that's why we use a Japanese name for it, umami. And we don't really have an English word for it. If you were to translate it into English, I would probably say savory is a good translation. But usually people just say umami. So umami is the taste of amino acids, specifically of glutamate and theanine. And so there's a few ways that you can sort of get an idea of what umami tastes like sort of in its purest form. So MSG is monosodium glutamate. So that's salty and umami tasting. The glutamate in there is an amino acid, and that tastes umami. And the sodium, of course, is sodium, which tastes salty. So you can't really get the idea of like pure umami from MSG. MSG is extracted from, or was originally extracted from seaweed. And so seaweeds have a lot of umami flavor too in them, while being less sort of intensely salty is just MSG. But the other really great way to taste umami, I think, is in gyokuro tea, especially if it's cold brewed. When you brew this tea cold, you extract a lot of the theanine and not as much of the other sort of flavor components in the tea. And so you really get something that is just like bizarrely intensely umami. It's almost like, it's not good really. It's not like delicious in the way that I would want to drink it every day, but it's really cool. And so if you have some gyokuro tea, or even you could probably do it with sencha if you cold brew it. If you have a good quality sencha, you'll really get that umami flavor, and it's pretty awesome to just taste it, even if it is kind of weird and like you don't think about drinking a cold, savory beverage being like delicious. Maybe you'll like it though. Maybe you'll think it's delicious. So this sencha I'm drinking. I got when I was in Japan at the sort of tail end of a field season, and so it is a pretty high quality, pretty fresh sencha. Well, not pretty fresh. It's like over a year old now, but it still has a lot of that umami flavor to it. Even though it's not the gyokuro that I wanted to bring. So why is gyokuro so high in that umami flavor is the next question. And it's not just gyokuro. There's other teas too. I mentioned matcha already. And then there are some Chinese teas that are also especially high in theanine. And one of those is Anji Baicha, which, sorry about my kettle here. Move it down. Oops. Sorry about the kettle noise. Anji Baicha is a Chinese tea that is made from an albino tea cultivar, and that was on the Instagram. If you look at my timeline, I put a split picture with theanine on the bottom, and some Anji Baicha plants on the top, and you can see the leaves are white. And there are a few other different kinds of albino tea cultivars that have like either yellow leaves or to varying different degrees of not quite green. So what makes these things umami? Well, let me make some more tea here. While you think about that, I just will have to say one of the things that I think is really cool and different about Japanese green teas is compared to Chinese greens or other teas in general, is that the second steeping is shorter than the first. For Japanese greens, you do the first steeping for like 30 seconds, and then, or maybe not even, for a breath or two, and then the second steeping is just like as fast as you can pour, and then the third you go back to longer, which is kind of interesting. Hello, Lindsay. So, so why is gyokuro so umami? Well, one of the things that's unique about gyokuro and about is also in common with the precursor to matcha is called tencha. Those are the leaves that. Eric says that works with many greens. Yeah, I guess you could brew lots of teas this way, but I think Japanese green teas are especially suited to that sort of longer brewing. So gyokuro and tencha are both covered with shade cloth for several weeks before harvest. And I was just reading the reading that I suggested in the syllabus, just looking that over again. And we don't really know, I guess, the origins of it, but it sounds like this was sort of an accidental discovery and that farmers were originally trying to protect their plants from frost by covering them to keep the heat in at night. And it also ended up blocking sunlight and gave them this sort of unintended consequence of there being a really, really super umami result. They also, fertilize those plants a lot. And so if you're adding extra nitrogen, that's bringing extra theanine up to the leaves as well, to make it extra umami tasting. So we've got shade cloth for gyokuro and for tencha. And then we've got these albino cultivars, like Anji Baicha, that are also extra high in theanine. And the way Anji Baicha in particular works is it's got a defect in its chloroplasts. Those are the little organelles in plant cells that do photosynthesis, that help it make sugars out of air and water. And there's a defect where they don't produce chlorophyll, they don't do photosynthesis when the weather is too cold, when the temperature is cold. Once it warms up, later in the spring, they turn green again, and the plant functions normally. But early in the spring, the young growth is white. And those leaves also end up being really high in theanine and very umami tasting. So what do those two things have in common? Well, they both have something to do with photosynthesis. So let me kind of walk you through what's going on here, I think. And to be honest, I think that this hasn't been actually fully elucidated, how this works, how these things get high in umami, high in theanine. So it's also related to catechins in tea. And we haven't talked about catechins in this series yet, so I won't say much more other than they are antioxidants in tea leaves. And what antioxidants do is they scavenge these super reactive oxygen molecules called free radicals that would damage the DNA of the plant or the proteins of it, right? They sort of scoop those up before they can do any damage. And one of the things that creates those oxygen radicals is photosynthesis. Just the process of doing photosynthesis causes the creation of these oxygen radicals that need to be scavenged by antioxidants. So the other piece that we need to know to understand this connection is that theanine is a precursor to catechins. So you need theanine to make catechins. So even though catechins don't have any nitrogen in them, part of the theanine molecule is used in manufacturing catechins. So here's my thoughts, and I think this is generally the thoughts in the tea literature as well, but I could be wrong. If you know something else, let me know. But I think what's going on is when you shade the tea, or when the chloroplasts are broken, like in Anji Baicha, photosynthesis isn't happening to the same degree, and that means it's not producing those oxygen radicals, and that means those catechins aren't as necessary for scooping up those oxygen radicals, and that means they're not being made, but the theanine is still getting sent to the leaves, and the theanine builds up, and the catechins go down. And so that is the case for both gyokuro and Anji Baicha. Compared to other teas, the theanine is higher, and the catechins are lower. And those two things together combine to give you that flavor, because the catechins are kind of bitter and astringent, or sweet, depending on the catechin. And the theanine is very umami. And so you go down in the sort of bitterness and sweetness, and you go up in the umami, and you get a really interesting, nice result. So I think that's how the sort of physiology of it works. Now, other things it does. In humans, in addition to tasting umami, theanine is also psychoactive. It's another one of the psychoactive compounds in tea, in addition to caffeine. So tea is drugs. Big surprise. This is why people like tea. I think it's why it initially was popular, and why it remains to be popular is because it has psychoactive compounds in it, like caffeine and theanine. So what does theanine do? Well, theanine has been shown to promote, I think it's alpha brainwaves. These are the sorts of brainwaves that you see in people who are sort of meditating, this sort of like awake awareness, awake mindfulness is promoted by theanine. And you can actually buy theanine in the like supplement section of, Whole Foods or CVS or whatever, as like an anti-anxiety supplement. Now, whether you get enough theanine from drinking a cup of tea to actually cause that is sort of unclear. And my just sort of like personal thoughts on that are you're probably not getting enough theanine unless you're drinking a lot of tea that is high in theanine. So, if you're sitting down and you're drinking, a bowl or two of matcha, or you're having a nice long session where you're drinking a bunch of sencha and gyokuro, or you are, I think probably certain pu'ers are high in theanine, although I could be wrong about that. Unless you're really drinking a lot of tea, you're probably not getting enough theanine to actually feel any difference from it. But I do think, personally, again, that it's one of the things that probably contributes to this feeling of being tea drunk, where when you drink a lot of tea, you feel pretty giddy, but it's definitely different than just being caffeinated. Eric says, so maybe that's why I get relaxed, and so I get the theanine and not the theanine and not the caffeine. Yeah, that's right. So Eric we talked last time about how he's really not very sensitive to caffeine, and so maybe you're getting all the theanine and none of the effects of the caffeine, and it's actually making you nice and relaxed, as opposed to other people who might be feeling the caffeine more. So it also might be that this theanine thing is kind of depends on your genetics, right? Maybe not necessarily the theanine itself, but in relation to other things that affect your mood, like caffeine. Poor, I wonder about other HI, drink lots of Hunan. Yeah, I'm not sure. I was sort of thinking, basically I don't know, but I was sort of thinking that the other kinds of teas where I've sort of felt that tea drunk feeling are like drinking a lot of raw pu'er. But it might be something else in there, or it might just be, psychosomatic. I have no idea. So, one of my favorite stories about tea, the origin of tea, has to do with caffeine and theanine. And this is a story from the Japanese tradition. Early on in Japanese tea was always been associated with Zen Buddhism. And this story is from the Zen tradition. It's of a monk who was meditating in a cave, a Zen monk, staring at a wall of a cave. That is a thing that you do as a Zen monk. And he's been meditating for many, many hours, and he falls asleep meditating. And if you've ever done meditation, you know that is not the goal of meditation. You're not supposed to fall asleep. You're supposed to be awake and mindful. And so when he woke up from his nap, he was super pissed off that he fell asleep while he was meditating, so angry that he ripped his own eyelids off and threw them on the ground in anger, where they sprouted into a tea plant. And then he could use the leaves from that plant and make a brew, make some tea out of that would keep him awake, but also promote that feeling of mindfulness, and he could use that as a meditation aid and not fall asleep while meditating anymore. And also, he had no more eyelids, so it was difficult for him to fall asleep. But yeah, so I think that's really telling about, this sort of origin story of tea includes both the caffeine and the theanine, the effects of both really in that story. Not explicitly, but I feel like it's implied. And those two molecules in tea are probably the reason why it spread throughout the world from China and has become now the most popular beverage in the world besides water. Now we've talked mostly about green teas, and I do want to mention before I wrap up, another thing that amino acids are important for, including theanine, is something that happens not really in green teas very much, but maybe in some. I'm thinking maybe actually it might be important in some of the Korean green teas. Maybe Eric, you can tell me what you think about this. Is something called the Maillard reaction. So Maillard is I think how you spell that. It's not pronounced like it's spelled. I think it's a French word. So the Maillard reaction is a type of chemical reaction. It's not one single reaction. It's a type of chemical reaction that happens only when you've got amino acids, sugars, and dry heat. It needs to be dry heat just because it needs to get hotter than boiling water gets in order for this reaction to happen. or this set of reactions. And so this is what's happening when you sear a steak, or when you caramelize onions, or when you roast a marshmallow. Roasting a marshmallow is actually a really good example of that, because that's what marshmallows, they're only sugar and protein, basically. That's all they're made of, just gelatin and sugar. And then when you toast that marshmallow, you get just a whole bunch of Maillard reaction. And you can think about all the aromas that are produced in that, all the volatiles that are produced in that. You can smell that sort of toastiness, that roastiness. And in fact, I had an amazing tea last night. I think it was amazing. It was a Laoshan black tea from Yunnan sourcing. And it smelled like straight up Swiss Miss hot chocolate, hot cocoa mix. Like, it smelled like those freeze-dried marshmallows that come in the packet, which I think is cool. I think it was a really good tea. Anyway, judge me if you want to. I think it was great. Tasted like Swiss Miss hot cocoa. I liked that. And so I think, Eric says you. I think that, very likely that comes from this tea being high in amino acids and maybe also high in sugars, extra high in sugars. And then during that roasting process, you get a lot of that Maillard reaction, and you get a lot of these pretty unique chemicals being produced that are uniquely produced by this Maillard reaction. So the other place you see that is like in winter sprout oolongs. I have another great tea that's from Song Tea and Ceramics. That's their Sinensis Shi winter sprout. This was tea that was harvested during sort of an unusually warm spell in the winter, where the tea plants sort of leafed out a little earlier than they were maybe supposed to, or maybe wanted to. And those leaves are going to be packed with sugars and amino acids that the tea plant uses as a antifreeze compound, basically, to protect itself from the frost during the winter. And so then when you roast that, you get these wonderful sort of caramelized sugar, caramelized gingery kind of notes in it. And it's really phenomenal, I think. So the reason I brought up Korean green teas is the first time that I had a Korean green tea that was really blew my socks off. I remember everyone that tasted it, we all kind of looked at each other and we were like, it tastes kind of like something. And then it was like, it tastes like cereal. It tasted kind of like that, whatever that flavor of just like cornflakes, right? That sort of cornflake sweetness. And that to me seems like one of those Maillard reaction kind of products where you're toasting the toasted cornflakes or something like that. And I don't know much about how Korean green teas are produced, other than that it's complicated. And so I don't know if there's actually an opportunity in there for that Maillard reaction. If there's a step where the leaves are being pan fried or something like that, or cooked in some other way that might get that. Let's see, maybe that's why Korea had a frost one year and it was amazingly sweet. Yeah, so yeah, definitely. Frost and the opposite, early leafing out, early spring. Those types of teas can lead to, or those types of weather conditions can lead to some really interesting flavors in tea, because the tea plants are sort of extra stressed at that point and producing all sorts of things to protect them from that frost. Including probably theanine, although I think another amino acid, proline, is usually used by plants in general more commonly as an antifreeze. Now, I don't know about tea specifically if it uses proline in the same way, but lots of plants produce extra proline in the winter and keep that around in their cells as an antifreeze. And I don't know why proline in particular. I couldn't answer that question right off the top of my head. But yeah, that's another one that'll participate in that Maillard reaction, and one of those Maillard reactions, and do its thing with sugar and heat and make something delicious. So unless you guys have any questions, I think that's probably all I have to say about theanine for now. And maybe someday we will have a much fuller picture of how theanine, catechins, and photosynthesis are all related. But for now, I think that story that I told is probably our best guess. But it's not my exact area of research, so I can't be 100% certain that maybe somebody hasn't already figured it out, and I just haven't come across that research yet. So as usual, I'm going to put this up on the Tea Geek YouTube channel in a few days. And if you have friends who you want to see this, you can share it with them in that way. And please, leave your questions. You can send me questions on Twitter, on Instagram, or you can leave them as comments on the videos. If there's something about theanine that I didn't address that you want to know, or something I said that wasn't clear, let me know. I didn't bring any papers today to hold up because watching the old videos, I realized you can't even read the title really. But I am still going to put sort of an annotated bibliography in the YouTube. And so if you've been coming to these Tea Science Tuesdays and you want to know more about the research papers that I've discussed, you can go over to the Tea Geek YouTube channel, and you can there's a playlist for Tea Science Tuesday, and you can see for all of those I've put a little annotated bibliography with just a few scientific papers and a short description of sort of what their main results are. That way, if you can't get access to it, then you can just read that short description. And if you want to read the full paper, you can let me know, and I can help you find it. So thanks for watching, and I'll see you next Tuesday, I think. I'll be around. Yeah, I'll be around next Tuesday. See you then. Bye.